Hi, I'm Luke McKinney, Prep 101's Physics 101 instructor. In this video we deal with the equations of motion and how to use them. Sometimes they get their own problems, sometimes they're a two-part problem with a forces or a momentum question, so double chance of using these.
The equations of motion are a beautiful set of equations because they give us a bunch of marks on the exam every year. They get questions to themselves, and they're very often a two-part question with forces connected by the acceleration. So how do we know we have an equations of motion question? Very handily, the key point is the idea of constant acceleration. If you have a constant acceleration, and that can include zero, then it's equations of motion. If you don't have a constant acceleration, then that'll be a conservation of energy problem usually, and that's later in the course. So how do you know you have a constant acceleration problem? Well, oftentimes you'll just be told directly in the text of the problem that things are moving with constant acceleration. Another type of problem is if something's falling in free fall. We know its acceleration is the acceleration due to gravity, 9.8 meters per second squared down. Or you might have some arrangement where you have blocks on a slope with friction and tension and all of that. We'll see that in later primers. But the idea is you do a bunch of force problems which give you the acceleration. And then that's a constant acceleration, because even as things move around, the whole arrangement of the situation isn't changing. So once you've got a constant acceleration, you can go straight into the equations of motion. So let's have a look at those now. Now, when we're dealing with equations of motion, as we saw, we've got a bunch of equations. We want to plug in numbers, but a lot of the numbers will be given to you as words rather than letters. For example, if something starts from rest, we immediately translate that as the old velocity is 0. Likewise, if something stops, that means the new velocity is 0. A special case is if something is dropped by something else, then it starts with the velocity of that object. For example, if I'm just standing here and I drop an apple, well, my velocity was 0. So the apple starts with a velocity of 0. But if a helicopter was flying along, you can see my amazing art there, with a velocity of 20 meters per second, and it drops a crate of supplies, then those supplies will also start with a velocity of 20 meters per second to the right, which is fun. Another value that very often turns up in these problems is g, the acceleration due to gravity near the surface of the Earth. If I drop this apple, I know it'll fall down, and the acceleration will be the acceleration due to gravity, 9.8 meters per second squared down. And that's the free fall acceleration. Now remember, that is near the surface of the Earth. If you're near the moon or a Jupiter or something else, there will be a different value of g, which you would have to be either given in order to calculate the problem, or it would be the only unknown value. They might have given you everything else, and then you can work out g in this situation. So what are these equations of motion? Well, the first equation of motion is the new velocity is the old velocity plus the acceleration times time. And if you want, you can write little suffixes like x or y on those. They apply in all the directions, but the key thing there is that I said the words, not the letters. I didn't say v equals v0 plus at, because exam questions don't tend to say v equals 7, a equals 3, t equals question mark. The questions are always set up like things like a truck is initially at rest and accelerates constantly for 60 seconds to a final speed of 90 meters per second. So you can see if we say the equation in the same words, new velocity, old velocity, things like that. It makes it much easier for plug things in to these equations. The other equations we have to play with, the new position is the old position plus old velocity time plus a half the acceleration times time squared, and the new velocity squared minus the old velocity squared is twice the acceleration times the change in position. Or sometimes people rearrange that as new velocity squared equals old velocity squared. You can see it's exactly the same equation, whichever you want. There's also a little sort of novelty one. Because the acceleration is constant, you can say that the average velocity is the new velocity plus the old over 2. That one's used a bit less, but it's on the course, so we might as well have a wee look at it. So once you have these equations, you can plug in Chug to solve pretty much any problem with constant acceleration. How do you know which equations to use? Well, you can just ram at them. Whatever numbers you're given by the question, you'll find one of the equations is only missing one of its values, and you'll always solve that one. Even if it's not the value you want, you'll find it'll then give you the value you want. But there's a thing to highlight here. We see this equation here doesn't have any time term in it. So that can help us choose which one to use. So if a question says, how long does it take a truck to stop? Well, that's time. So it'll be one or both of the time equations. But if it says a truck skids to a halt in 30 meters, that's a distance, not a time. So that'd be this equation here. And that's the distance taken there.
I hope that was useful. There's plenty more videos in the playlist, but what's even more useful is lots of exam examples and exam specific advice. And that's what we do in the prep sessions. So join the Prep 101 Study Hub Facebook page to find out when those go on, and many of them are even free, so you definitely don't want to miss those. Hope to see you there.